line and plane. So different interpretation of the object. If you talk about this corner, here edge, point, surface, all interpretations are there. So we're talking about this. If you only talk about a point, that is about a sphere, where how can you gauge a sphere? Where is the imaginary point? That is a center point. So different ways we devise, but a single rule we use. And coordinate system is from where our 0, 0 reference is. And that is the vital and important part. And if you talk about the basic dimension, inside your drawing, this basic dimension never changes. You cannot apply tolerance to a basic dimension. I will discuss just in a minute. So if you see this particular cylinder's location, maybe from some other part at a particular location in X direction and Y direction, and you can see the location is absolute, so that other pin or hole will get assembled to this. So you cannot have a, the tolerance to this. So this is a basic dimension, but you can have different other control. So how to deviate from the standard to the non-standard, but still that is not getting rejected, that is the part of JD&T. So what are the different rules that I will show you? And finally, a symbolic language, that means if all the controls, tools where you drive inside your imaginary world of JD&T, but that always cater to your real world. So these are the different, the JD&T codes, how we write, but within a minute, I will explain bit by bit. So this is what a simple JD&T applied drawing looks like with a various tool. The logic of JD&T here you will find through a geometry control tools for a positioning, perpendicular, parallel, profile, run out, and flatness, and different other tools also you have. And you can see this is applied here over the drawing. That means this hole is positioned and the tolerance here is 0.5, not this tolerance, which 18 plus minus 0.5. This is the dimension tolerance, and here this is the geometric tolerance. So both are different. So to geometric dimensioning tolerance and only dimension tolerance, both are quite different. So this is JD&T, and this is only the normal ordinary dimension with tolerance. And next is you can have different interpretation here, like for the profile, how you interpret. Profile is basically the complete outer boundary. How do they deviate? If you see about the bore and its diameter, how do it manage for deviation? And next is the everything tool, that is the size. How do you manage the size? How do you control the form? Form may be the flatness, maybe the cylindrical, and maybe the perpendicular. And orientation, you can set your angles, and location is basically the positioning exact point. So these four things you control through your JD&T tools. That is the logic. And here you can see the flatness that controls, and from this bottom surface the 0.25 flatness is allowed, so that during the inspection we can reject all the parts which are above 0.25. But how do you know that this is 0.25 is okay? That is the part of the JD&T. That means when you talk about a hole and when you talk about a shaft, how do you know that what is the best diameter and the worst case for your shaft and worst case for your hole, both will fit? That is the part of the JD&T encoding and decoding. That is what the encoding. So once you interpret it perfectly, then you can guarantee it. And finally, the feature control frame, where you arrange all the geometric dimension and tolerancing symbols, that is feature control frame. And these are the red highlighted. You can see all these are feature control frames. And next is the basic dimension. So here you can see the basic dimensions are highlighted here. The 25 typical location where from the coordinates 0, 0, wherever it is there, that we'll discuss later. But this 25 you cannot vary, and this 45 is a typical position, and this 45 also is a typical position. So all this typical dimension you never try to apply JD&T, because these are basic dimension and critical dimensions. So how do you know that which is a basic dimension, which is not? So that also is a part of JD&T. Next is the datum. Datums, as I discussed, are the gauge reference and quality perfect parts, but while manufacturing you will never get the quality part. So most of the people, they say that this is the datum, inside the part my datum is there. No, your datum, the A, which is the perfect surface, is your gauging plate, is your gauging reference, is your inspection instrument, not inside the part. Even though you allot the datums is a flat plane, maybe with respect to the three different direction, XY, YZ and ZX. So these are the flat reference, perfect reference, but after manufacturing parts cannot be perfect. So this datums, most of the people, they say that this is inside the part. No, this is inside your inspection instruments. So these